So, good day engineers. Para sa video natin na to, ang i-discuss natin will be steps number 9 to 12 for the design of double reinforced beam. So, this is just a continuation of our previous videos on the design of double reinforced beam. So, let's start with step number 9 for this one. So, determine the theoretical value of the compression steel stress and check whether the steel is yielding by using the strain diagrams. So, dito, ang gagamitin natin to determine the compression steel stress will be the strain diagram. Syempre, the one shown here. So, syempre, ang kailangan lang natin na strain or na value ng stress dito is compression steel stress. Why compression steel stress lang? Kasi we always assume na ang tension steel stress lagi ang yielding. So, we are always using Fy. Then, dun sa part naman ni compression steel stress, kailangan natin i-validate kung mag-yield yung steel or hindi dun sa design process. So, to determine that one, syempre, using the strain diagram, we know na yung height nito is a value C. Tapos, we know that this one is a D prime. Then, we also know that this value is a value C minus D prime. So, using similar triangles for this step number 9, we can have C over 0.003. That is equal to a value C minus D prime over the strain, which is ito. So, that is F prime S over ES. So, dito, ito dadali natin doon. Then, this one, papunta dito. Then, yung C, mapupunta rito kasi that is 2 divided by C. So, that will be equivalent now to F prime S. Syempre, si ES is 200,000. Then, we can have 0.003 times C minus D prime over the value C. So, further arranging this one, si 200,000 i-multiply natin kay 0.003. So, we could have a value F prime S is equal to 200,000 multiplied by 0.003 is 600. So, that is 600 C minus D prime over C. So, kung kabisado nyo na to, yung compression steel stress na value natin, okay lang na gamitin nyo siya directly. Dinederive ko lang siya for the purpose na kapag nakalimutan natin yung value na yan, at least may sasalba tayo nung strain diagram. So, from this compression steel stress, syempre i-check natin if that is yielding. So, if the steels are yielding, so if F prime S is greater than the value Fy, so ibig sabihin, yung compression steel natin nag-yield. So, that means we have to use Fy. But, if F prime S is lesser than the value Fy, therefore, yung compression steel natin does not yield. So, that means we have to use yung calculated na F prime S coming from this equation. So, dito sa equation na to natin, kukunin yung F prime S natin. So, that will be step number 9. We now proceed to step number 10. Sabi dito, determine the second nominal moment. The second nominal moment can be produced by having Mn is equal to Mn1 plus Mn2. So, si Mn1, nakuha na natin yan from our previous step from our previous video, si MN1 nanggaling siya dun sa first stress diagram. Ngayon, our MN2 will just come from this equation. And since meron na tayo from our previous steps ng value ni MN1, we just arrange this value or this equation. So we could have MN2 is equal to Mn minus Mn1. And we all know that the value Mn is equal to a value Mu over phi. So we could have the value Mn2 as Mu over phi minus Mn1. And take note that the value Mu here is the value Mu coming from the structural analysis. So galing to ng STAAD, ng ETABS, or kung minano-mano natin yung pagkuha ng moments dun sa structural member natin. So itong Mu na yon yung sinasabi at hindi yung capacity na galing sa analysis. So that is coming from the structural analysis itself and not the moment capacity coming from the analysis of singly or analysis of doubly. So that is step number 10. Now we proceed to step number 11. Sabi dito, determine the second steel area by summing up moment to the compression steel. So for this step number 11, we will be needing the second stress diagram, which is yung C2 and the T2. So alam natin that that will also produce a statical equation. C2 is equal to T2. And we have also, or we can sum up also moments using this equation. So sabi sa step 11, let's sum up moments to the compression steel area para makuha natin si second steel area. So we have to sum up moments at the compression. So that will be equivalent to the value Mn2. Alam natin na yung Mn2 is nakuha na natin from the previous step, which is step number 10. So ibig sabihin, ang magiging unknown talaga dito is yung AS2. Kasi ang equation natin, if we sum up moments on the compression side, is Mn2 is equal to AS2 Fy times the moment arm D minus D prime, which is ito. So ibig sabihin, arranging this term, kasi given na nga si Mn2 from the previous step. So that means we can get AS2 equal to Mn2 over Fy times D minus D prime. So ito na ngayon yung kailangan natin gamitin to determine the value of the second steel area. So yun lang naman yung gustong ipagawa sa atin ni step number 11. After step number 11, we have to proceed to step number 12. Sabi dito on the step number 12, determine the total tension area by adding the first steel area and the second steel area. Alam natin na yung AS1 natin nakuha natin by getting it through Romax BD. And yung AS2 natin nanggaling dun sa previous step natin, which is ito. So that is AS2 is equal to Mn2 over Fy times D minus D prime. Adding these two values, so AS is equal to AS1 plus AS2. So we could produce yung total tension steel area, which is yung kailangan natin para ma-design yung reinforcement nung given natin na beam. So from this one, we can say na meron siyang general formula, which is AS. So that is equal to rho max BD plus Mn2 over Fy times D minus D prime. Ito ngayon yung equation natin na gagamitin for our step number 12. So that will be all for steps number 9 to 12 on the design of doubly reinforced beam. Again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.